Hey everyone, so I just wanted to quickly go over how air conditioners and refrigerators work. I'll just start by clarifying that this isn't meant to be a detailed explanation of all the internal processes. However, it's to help you get the gist of the point of the system and the concept that it operates on, and also how simple it actually is. So this is the evaporator. This is cold, right? That's why you're seeing condensation in it. I just shut it off. This is a compressor, and this is a condenser. So the reason these may not look familiar is because they don't have fins on them. So these are aluminum. This is another evaporator. It's not a part of that system. It's just a different one that I brought out to show you. So these fins simply help to exchange heat between air and copper tubing. And condensers also look very similar to this, but they're usually thinner. Right, so what the compressor's job is to pump refrigerant, and also to, well, actually it does more than that, but anyway. So another part I neglected to mention, but what I've gotten to anyway, is the dryer, or filter dryer. I'm not gonna explain that in this video because I'm just covering the basic concept of vapor compression refrigeration, that's all. And this is the capillary tube, which is a form of metering device. So the way air conditioners normally work is and refrigerators too, is they transfer heat from inside the area that they're cooling to outside, and that's what this does. So this gets colder, and what that means is that it causes heat from the air just to be absorbed into this. So this is cold because the refrigerant inside it is cold, so therefore what this does is it transfers heat from the surrounding air, or water in this case, because I fill this with water, into the refrigerant, and then the refrigerant is continually sucked by the compressor from the evaporator through here. So the evaporator actually ends here, and then this is where it enters the compressor, and then the compressor pumps that refrigerant, that warmed refrigerant, because it contains the heat from the air in your room or water, out into the condenser. It starts here. And the condenser in this case, and in many cases, is a thinner tube than the evaporator, and it just keeps pumping into the condenser as well. It's a continuous loop. In this case, this unit doesn't use an expansion valve, it uses a capillary tube. So now for the metering device. So the metering device in this case is a capillary tube. So a capillary tube's purpose is to restrict the flow of refrigerant in such a way that it causes the evaporator's pressure to decrease, since the compressor is constantly sucking from it, and it causes the condenser's pressure to increase because the compressor is constantly pumping refrigerant into it. So a heat transfer is basically occurring from the evaporator to the condenser. So while it's not the case with, while this unit obviously has both a condenser and evaporator inside the room, air conditioners have the condenser outside. I just haven't put mine outside yet. So it cools, sucks the heat out of the air and basically transfers it to the condenser, and then the condenser just blows it outside. So the compressor, because of the metering device, which restricts refrigerant flow coming from the condenser, what it ends up doing is it causes the pressure to become high in the condenser, which is why the condenser is called the high pressure side, or HP side, and it's also the hot side of the system. So the compressor keeps pumping refrigerant into it until it condenses into a liquid, and that condensation process helps the refrigerant reject heat too, and then oftentimes a fan blows that heat away. So basically, it's almost like it's squeezing the heat out of the refrigerant, and then it pumps it back around. So the condenser ends here, well, here technically. Then the refrigerant passes through the filter dryer, which is this, and then exits into the metering device, the capillary tube, and then that process starts over again. So now for the evaporator side of that process. So the refrigerant ends up exiting the metering device. Well, it kind of trickles from the metering device into the evaporator. So in this case, unfortunately, is not very clear, but the capillary tube is attached to the beginning of the evaporator, which is right here, and then refrigerant kind of sprays in from the condenser, and it rapidly evaporates in the evaporator because the pressure is so cold, and then it flows up, and then that evaporation causes this tube to become cold, right? So it's essentially a refrigerant loop driven by the compressor. And well, so both air conditioners and refrigerators do this. Not all of them work like this, but the vapor compression systems do work like that. So yeah, that's my oversimplified explanation. I omitted the more complex details, because the whole point of this video is to be extremely simple, so that anybody who is just learning about this will understand it more easily, because these systems do get awfully complicated if you're discussing the technical details of what affects expansion and condensation and all of that stuff, and how the compressor works internally, and what's actually happening in the evaporator line or the condenser line, because the condenser isn't entirely liquid. For example, the beginning of it may contain some gas, and then some parts of it contain liquid, and the same goes for the evaporator. So yeah, that's just how it is, and I hope that you gained I hope that you benefited from this video, and thanks for watching.